Okay, guys, now that we have learned about what a function is and is not, let's talk about if the function is linear or nonlinear. And again, we're going to look at a couple of different representations. So functions that form straight lines are called linear functions. So if you have a straight line and there's no curve, it is linear. So all lines are functions except, if you recall, the vertical line. So the line that goes up and down does not pass the vertical line test. So, but you do need to understand that all lines except the vertical line, so if we have a line that slopes up, a line that slopes down, or a line that has a slope of 0, it just goes from left to right and doesn't go up or down, all three of these are functions and they are linear. So these are the three lines that are functions. So let's take a look at these three functions that are linear and let's look at their equations. What we need to check are the exponents on the variable. So I'm going to be looking at the y and the x, and I'm going to look at their exponent. Notice they don't have an exponent written, so it's understood to be a 1. And then here, we don't have the x at all, but all of the exponents on our variables x and y are 1. That is how I can tell if an equation is linear or not. Functions that do not form straight lines, these are all functions, but they do not form a straight line. These are non-linear functions. These graphs do pass the vertical line test, making them functions, but they're just not linear. Let's take a look at the exponents on the variables of these non-linear functions. So they're all functions, but they're non-linear. So notice the exponent on the x's. These are not a 1. This is what gives them their curve. It makes them non-linear. So to determine if a relation is a function, non-function, linear, or nonlinear, we can use an input-output table to graph the relation. Typically, guys, we are going to use the input values -2, -1, 0, 1, and 2, whether we have a horizontal table or a vertical table. This way, we can see what the graph looks like on the left side of the coordinate plane, in the middle, and then on the right side. So these input values, okay, they divide up. So the -2 and -1 are on the left side, so I can see what the graph looks here. My 0 input value will let me see what it looks like on the y-axis, and my +1 and +2 will let me see what the graph looks like on the right side, so I can get a complete picture of my relation to see if it's a function or not, and linear or nonlinear. So let's do this. So we are going to use these input values. We're going to input these values in for x and use order of operations. So 2 times -2 is -4 minus 3. So our output value is -7 when x is -2. So this is an ordered pair, -2, -7. So I'm going to plot that. Now we're going to input -1. So we have y equals -2 minus 3. And so the output value for when x is -1 is -5. So -1, -5. Then we're going to put in 0 for x. 2 times 0 is 0 minus 3. I get y is -3. So we're going to plot 0, -3. Now let's plug in 1 for x. So you see how this works? Really easy. And our output value is -1. So we're going to plot 1, -1 in our last value. 2 times 2 is 4, minus 3 gives us 1. So 2, 1. So you can see if we were to draw a line, this is a function and it's a line. It's linear. Okay, you see the word line and the word linear? So this is how you can tell. So let's do a few more. So we're going to plug in. We're going to use parentheses when we plug in. We're going to square -2 times -2 gives us 4 minus 1. That gives us 3. So we're going to plot -2, 3. Now let's plug in -1 for x. -1 times -1 is +1. And 1 minus 1 is 0. So -1, 0. Now we're going to input 0 for x. 0 times 0 is 0 minus 1, and I get -1. So 0, -1. Now we're going to plug in 1. And we get 1 times 1 is 1 minus 1 gives us 0. So we have 1, 0. So we can see it's not a line. And then lastly, let's plug in our 2. We're going to multiply 2 times 2 is 4, minus 1 gives us 3. So 2, 3. So this is a parabola, and it is not linear. Whoops. But it is a function. It passes the vertical line test. So this is a function, but it's not linear, so non-linear. And you could tell that this exponent was not a 1. That's how we could know without doing all this, our graph, this needed to be an exponent of 1 to be linear. Okay, let's do another one. We have y equals, I have a negative from the equation. Let's use parentheses. So order of operations, we have -2 times -2 times -2. That's -8. -8 times this understood -1 is +8, and that gives us 6. So -2, 6. Then we're going to plug in, so I have negative from the equation, use parentheses to plug in our x value of -1 cubed minus 2. Exponents first. -1 times -1 times -1 is -1. -1 times this understood negative is +1, and we end up with -1. So we have -1, -1, and then let's plug in 0. So 0 times 0 times 0 is 0 times this negative is 0. So we end up with -2. So 0, -2. And then we're going to plug in, so we have negative from the formula, the equation I should say. This is going to be +1 times this negative. That gives us -3. So 1, -3. And then lastly, we have y equals negative, and then we're going to plug in 2, and it's cubed minus 2. So 2 cubed is 8 times that negative out front, and that gives us -10. So we have 2, -10, and it's like way down here. So this looks like this. It curves and then kind of goes up. We can tell it's not a line. It is a function, but it's non-linear. And again, this little exponent not being 1 told me that. Okay, so We're not going to graph these, but I'm just going to let you know this is going to be linear because my exponents are 1, and we know, and again, linear. So I want to do this one. Okay, so this time there's really nothing to plug in. Here are my input values, but it says y is -4. So all my y's have to be what the rule says. It says y is -4. So when we plot these, so this equation does not have an x. So when we plot these, we have -2, -4. We have -1, -4, 0, -4. You can see that the horizontal line is being created. And we know that this passes the vertical line test. So it is a function and it's also a line. So it's linear. And let's do this one. This time I don't have input values because the rule says x is -4. So now no matter what my y value, it says x has to be -4. So let's plot this. So we have -4, -2. We have -4, -1. We have -4, 0, -4, 1, and -4, 2. So you can see that when we have x equals some number with no y variable, we have the vertical line. So this is not a function, but it still is linear because my exponent is 1, but it's not a function, but it is linear. Okay, so summary. All equations with an exponent of 1 are lines. All these graphs are functions except the vertical line. These equations look like x equals some number. Okay, so this is the vertical line, which is linear, but not a function. Equations with exponents that are not 1 are nonlinear graphs. So if we have y equals 3x to the second, this is nonlinear. So let's talk about nonlinear graphs that are not functions. So we've looked at linear functions, we've looked at nonlinear functions. What about, and we've also looked at linear non-functions. So what about a graph or a relation that's not a function and nonlinear? This is what it looks like. It is a horizontal parabola. So it looks like this. It doesn't pass the vertical line test. We know it's not a function and we know that it's not linear. And this is what its equation looks like. So just make sure you jot this in your notes. So when you have y squared is equal to something like 3x plus 1, you're going to get this type of graph. Okay, so pause the video, jot these down, and just determine if it's a function, not a function, linear or nonlinear. Okay, in number 1, I can tell that this is non-linear because this exponent is not a 1. This is the parabola. So I'm just going to do a quick sketch if you want to add this to your notes. So this is a function. So most everything we look at, guys, is a function. Okay, in this, I'm looking at the exponents. They are 1, so this is linear. And it's a graph that slopes down. So this is a function. And again, you can add this little sketch to your notes. That would probably be helpful. This graph is linear, or this equation is linear. The graph looks like this. So it's linear because my exponents are understood ones, and therefore, and it is a function. Here's the graph that's the vertical line. When we just have x equals some number, this is the vertical line. It is linear, but it's not a function. Number 5 is the horizontal. This is time we have y equals some number. We don't have the x in there. So this is the horizontal. line. So yes, it's linear and it is a function. Number 6, this is nonlinear. This 3 made it nonlinear and it looks like this. It's called a cubic function. You don't need to know that, but this is what it looks like and it is a function. And then we just demonstrated that when we have y squared, first of all, we know it's nonlinear because this exponent's not a 1. And it is the horizontal parabola. It doesn't pass the vertical line test, so it's also not a function. Okay, so we can see that 7 is neither linear or a function. So just kind of remember what this equation would look like. We see that number 4 is linear but not a function. So those are a few unique relations. And I hope this helps.